Lean on me when you're not strong, and I'll be your friend. I'll help you
7.2. So some key concepts from here. A function is invertible if the following statement is true. Okay, and I know this might look a bit confusing, and it also works the other way as well. So if this composition of functions comes out to equal x by itself, then you have two inverse functions. So an example of this would just be like, let's say f of x equals x squared, right? And g of x equals square root of x. Then let's see if this actually holds true, because these two we know are inverses, but let's check. So let's say f of g of x, right? Let's see what that equals. So f of g of x. So this g of x is acting in the x spot on f. So this is going to be squared, okay? So then, as we know, this equals x, so this is good. These two are inverses of each other, okay? All right, moving on. So a function, a function has to be one-to-one for it to have an inverse. And what one-to-one means, so one-to-one, that means when you have only one value of c, basically, so we have a function, and for every c value that it produces, or for every y value basically, there can only be one solution. So 1x for every 1y. So for example, let's see. We have, let's see this, whoa, okay, that was a bad line, hold on. Alright, so let's say we have a function that goes like that, okay? So for one-to-one, I like to do the horizontal line test, which is basically you just draw a horizontal line straight across. So let me attempt to draw straight lines. So these are kind of horizontal. Anyways, so basically, for every line that I'm drawing, it should only hit the graph one time for each line that I draw. So here it hits, right here. So that's good. Once, 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 and so on. Okay, so this would be a one-to-one function, since horizontally, I guess it qualifies as a function in a way. Whereas if we look at another graph, let's say a parabola, so let's say we have something in like a U shape like this, or something like that. Let's try the horizontal line test here. So down here, it doesn't even, okay, it's not touching the graph, all right. And then as we get closer though, okay, so let's say right here, pretend this is touching. So it does touch at one point, at the very vertex, right? So here it still qualifies, it's one-to-one. But then as you get up higher, see how it crossed in 2 points. So this right here, because it crossed more than once, that would not be an invertible function. Okay? All right. So moving on. Now with inverse functions, the domain and range switch. So let's say we have an f of x, right? So our given function. And let's say domain is d. Okay, so d is just the name of the domain, and it's from a to b. Okay, so from x equals a to x equals b. All right, and range of r. We're just going to keep it simple here. So range of r, and the y values range from c to d. Okay, so then over here we have our inverse function. So whatever is the inverse of x, we're just speaking generally here. So this domain now, because they switch, this is going to have a domain of r, okay? And in the sense that the x values now range from c to d, and the opposite for its range. So its range will now be d. So its y values will go from a to b. So this went here, and and this went there. Okay? They switched. Okay? So, let's see. All right, we'll go on to the next thing. So how to find an inverse function. The first step is to switch your x and y. So example, let's say we're given f of x equals 3x. We'll just do something simple for demonstrative purposes. So f of x is kind of like the same thing as y, right? So we have y equals 3x. So first of all, we're going to switch our x and y. So now we have x equals 3y. Okay. All right. So now step 2, last step, it's pretty simple. Solve for y. So solve for y. Now if we solve for y, we'll get y equals 1/3 of x. Correct? Okay, so this would be our inverse function. This is like our f -1 x. So this is our inverse function of our original f of x equals 3x. Okay? That was pretty simple. Alright, now we'll get into the tougher stuff, the more calculus-based things. So derivatives of inverse functions. Okay, so first of all, we have f of x and g of x are inverses. That'd be useful to know. Okay, and we have this other formula that we can derive, but I'm not going to go through the proof, but it says that g prime of b, so some value b, equals 1 over f prime, that's an f, of g of b. Okay, so I know this looks a bit complicated, and I remember when I was learning this in high school, my brain was in knots trying to figure this out. But I'll do an example so you can see how it can be applied. So, example. It becomes a bit clearer after you see an example. So, let's say we have f of x equals x to the 3rd. Okay. Therefore, g of x would equal the cube root of x, right? They basically undo each other so that, remember the composition? When you put g of x into f of x, then you're just going to get x. Anyways, okay, so let's say I give you the question, what is g prime of 8 then? Equals what? Okay, so g prime of 8, according to our formula, let's set it up. Okay, I'm going to go on to another slide so I have more room. Let's see, so g prime of 8, equals, according to the formula, we have f prime of g of 8. Okay, and that's just referring to our formula, which you can also find in the book just as easily. Okay, so then the question is, well, we had g of x here. We knew was cube root of x, right? And I'll rewrite this. F of x was x to the 3rd. Okay, so, alright, now we just kind of plug things in. But, g of 8, that's going to be, if we plug in an 8 here, the cube root of 8 equals 2. Okay, so now we know what goes in this spot, right? That's going to be 2. And then, so we can just rewrite this real quick. 1 over f prime of 2. See, now it doesn't look so intimidating. So now we have to figure out what f prime of 2 is. So f of x we know. So f prime of x is going to just be the first derivative, so 3x squared. And when we plug in 2, we're going to get 3 times 2 squared, which equals 12. Okay, let's see, 4 times 3, 12. Okay, so then, let's see, we just get 1 over this answer, which is 12. So 1 over 12 is our final answer. Okay? Alright then, done with that example.
Bye.